All right, let's journey back, way back. We're going to the dawn of time itself, to that murky cosmic twilight, when the very first lights in the universe were just starting to flicker on. But what if those first lights weren't what we think they were? What if they were powered by something we can't even see? We're diving into a theory that could totally rewrite the first chapter of the cosmos.
You know, we think we have a pretty good handle on how stars work. They're these giant balls of gas, mostly hydrogen and helium, right? And they crush atoms together in their cores. It's called nuclear fusion. That's what makes our sun shine. But what if the universe's first ever stars played by a completely different set of rules? What if they were powered by a totally different kind of fire?
And this is where our mystery really begins. The James Webb Space Telescope. I mean, this incredible machine is peering back into the universe's infancy, and it's finding weird stuff. 3 objects, to be exact, that just don't add up. They're shining with an intensity that makes no sense. They're way too brilliant to be a single star, but they're too small and cool to be one of the first galaxies. They just don't fit our models. So, of course, the first thing scientists do is try to make sense of it. They try to fit these strange signals into the boxes they already understand. Is it a star? Okay, no. Is it a galaxy? Nope, doesn't fit. Every time they tried, the data just refused to cooperate. It's like a cosmic crime scene when none of the usual suspects fit the description. And this really lays out the puzzle perfectly. So, if these things were normal stars, their crazy brightness should mean they're unbelievably hot. But they're not. They're actually kind of cool, temperature-wise. Okay, so what if they're baby galaxies? Well, then they'd be these huge, sprawling collections of stars, not these super bright, dense little objects. It's a genuine cosmic head-scratcher. So, what happens when all the normal explanations just completely fall apart? Well, that's when you need a bold new idea. And this one sounds like it's straight out of science fiction, but it might just be the perfect explanation for what the JWST is seeing. It's called the dark star theory. Okay, so here's the absolute key. A dark star isn't powered from the inside by fusion like our sun is. No. Its engine is made of dark matter. You know, that invisible, mysterious stuff that makes up most of the matter in the entire universe. And this engine doesn't fuse atoms together. It smashes particles together until they annihilate each other. So here's how it would supposedly work. You get a massive cloud of hydrogen and helium in the early universe, and it starts collapsing under its own gravity. But right at its heart, there's a super dense clump of dark matter. As everything gets squeezed together, those dark matter particles start colliding and just poof, they annihilate, releasing a flood of energy. This energy pushes outward, heating the whole cloud up, but, and this is crucial, it stops it from getting dense enough to actually start nuclear fusion. What you get is a star powered by darkness. And look, if these things really existed, they would have been monsters. We're talking about objects on a scale that just absolutely dwarfs anything in our own solar system. It's almost impossible to imagine.
Just let that number sink in. Not 100 times bigger, not 1,000, 10,000 times the mass of our own sun, all packed into one single object.
And all that mass being fueled by that dark annihilation engine would shine with the light of millions of our suns put together. These things would have been the absolute brightest objects in the early universe. Cosmic lighthouses, for real. But here's the twist. Here's the part that brings us all the way back to what Webb actually saw. All of that incredible energy coming from the dark matter would cause the star to swell up, to get huge and kind of diffuse. And because its surface area is so gigantic, even though it's pumping out unbelievable amounts of energy, its surface temperature would stay relatively cool, which is an exact match for the weird objects in the data. It all clicks. Okay, so we have a wild theory that just so happens to fit the evidence perfectly. That's already amazing. But this is where the idea goes from just being fascinating to being fundamentally important. Because it might just solve one of the biggest mysteries in all of cosmology. See, astronomers have been scratching their heads about this for ages. When we look back at the early universe, we see these gigantic, supermassive black holes, but there just wasn't enough time for them to grow that big through normal means. It's a huge cosmic cold case. Dark stars? They could be the missing link. The life of a dark star would be totally unique. It would burn incredibly bright for millions of years, just gobbling up its dark matter fuel. But once that fuel is gone, all that outward pressure just vanishes. There's nothing holding it up anymore.
And that star, all 10,000 solar masses of it, undergoes this catastrophic collapse. It doesn't explode, it implodes directly into a massive black hole, giving the universe's monsters a huge head start. These stars didn't just die, they became the seeds of giants.
The James Webb Telescope has really just opened a brand new window into the dawn of time, and it's already showing us things that are challenging everything we thought we knew. Finding these potential dark stars is just a reminder that the universe is still packed with profound secrets. It really makes you wonder, if these monsters were lurking out there all along, what else is hiding in the cosmic dark, just waiting for us to find it?